In this video, we'll be looking at different solutions to problems from section 7.3. And in this first problem, we want to go ahead and rewrite cosine of 4 raised to the x in terms of cosine by lowering powers. So initially, we want to go ahead and write our reduction of powers formula down. And recall that this is given by cosine squared x is equal to 1/2 plus 1/2 of cosine of 2x. We'll be using this identity to simplify this expression here, rewriting our cosine raised to the 4th x as cosine squared x raised to the 2nd. This is going to be equal to 1/2 plus 1/2 cosine of 2x, and this is all squared. So now simplifying this, we'll get that this is equal to 1/4 plus this should be 1/2 of cosine of 2x plus our 1/4 of our cosine 2x raised to the 2nd. So now that we're here, we're going to go ahead and apply our reduction of powers again to this term here. And we'll get that this is 1/4 plus 1/2 cosine of 2x plus a 1/4 times a 1/2 plus 1/2 cosine of 2x. Now that we have this formula at the bottom, we're going to go ahead and simplify it. So let's rewrite it real fast. First, distribute out the 1/4 to this term here, and we'll get that this is equal to a 1/4 plus 1/2 cosine of 2x plus a 1 divided by 8 plus a 1 divided by 8 cosine of 2x. Oh, sorry, this should be a 4x here. This is also a 4x. So now we're just going to go ahead and add the like terms together. We'll add 1/4 and our 1/8, and we're left with this being equal to a 3 divided by 8 plus a 1/2 cosine of 2x plus a 1 divided by 8 cosine of 4x. And this is going to be our solution. Let's move on to another example. And in this example, we want to use the half angle formula to evaluate sine of 3 pi divided by 8. So first, let's go ahead and write down the formula for the half angle formula of sine. This is given by sine of theta divided by 2 is equal to a plus or minus square root of 1 minus, cosine theta, all divided by 2. Now let's first go ahead and find what our theta divided by 2 is. So set theta divided by 2 to be equal to 3 pi divided by 8. This gives us that our theta should be equal to 3 pi divided by 4. And since we're evaluating sine of 3 pi divided by 8, we know that our angle theta is in the first quadrant, which means the output value is going to be a positive number, and so we want to be looking at the positive square root value. So go ahead and plug all this information into our formula, and we'll get sine of 3 pi divided by 4 divided by 2 is going to be equal to the square root of 1 minus cosine of 3 pi divided by 4. All of this is divided by 2. Evaluating our cosine of 3 pi divided by 4, and we'll get that this is going to be equal to a square root of 1 minus square root of 2 divided by 2 with a negative in front. All of this divisible by 2. Therefore, this is going to be equal to the square root of 1 plus the square root of 2 divided by 2, all divided by 2. And this simplifies to be a square root of 2 plus square root of 2 divided by 4. Now this next example, let's go ahead and look at a function that involves an inverse trig function. And we want to find an expression in x for the following function: tan evaluated at 2 sine inverse of x. The first thing that we're going to do is we'll set y to be equal to our sine inverse of x, and this gives us the equivalent expression that sine of y is equal to x. Therefore, if we represented this using right triangles, then in this right triangle here, we have an opposite side of length x, a hypotenuse of 1, an adjacent side square root of 1 minus x squared, and an angle given by y. Now, if we wanted to rewrite this in terms of x, we have to get rid of this to evaluate sine x. So we're going to rewrite this using a trig identity, and this is going to be the double angle formula, where we have tan of 2y is equal to 2 tan of y divided by 1 minus tan squared y. Now, since we have y is equal to sine inverse of x, we can go ahead and evaluate our tan of y using this right triangle over here. So rewriting this, we get that this is going to be a 2 times a x divided by square root of 1 minus x squared, all divided by a 1 minus x divided by the square root of 1 minus x squared squared. Now we need to go ahead and simplify this. So we want to get rid of this term on the bottom by combining it into one term. So this becomes a 2 times x divided by the square root of 1 minus x squared, all divided by the square root of 1 minus x squared squared, divided by the square root of 1 minus x squared squared, minus x squared divided by the square root of 1 minus x squared. Now, since we're going to be dividing fractions, well, let me simplify this one step real fast. This is going to be a 2x divided by the square root of 1 minus x squared, all divided by a 1 minus 2x squared divided by the square root of 1 minus x squared squared. So now, since we're dividing a fraction by a fraction, this is the same thing as flipping the second and multiplying, which means that one of the square roots of 1 minus x squareds is going to cancel out with this square root of 1 minus x squared here. So rewriting this, we'll get that this is going to then be equal to a 2x times the square root of 1 minus x squared, all divided by a 1 minus 2 x squared. And this is going to be our solution. Now we'll look at one more problem. And in this last problem, we want to write the following sum as a product. So since we're writing this as a product, let's rewrite our formula real fast. Sine x minus sine of 2x. And what we want to recall is one of our product to sum formulas. And this is going to be given by the following. This is a sine of a plus b minus sine of a minus b is going to be equal to a cosine a sine of b multiplied by 2. And what we'll do is we'll set this equal to what we have. So we'll have a sine of a plus b minus our sine of a minus b is equal to 2 cosine of a sine of b. And this gives us an equality between our arguments. This says that x should be equal to an a plus b, and a 2x should be equal to an a minus b. And what we'll do is we'll use these two different identities to solve for what our a and b have to be. That way we can just plug them into our formula and we have our solution. So looking at this formula first, we can subtract b on both sides, and now we have a in terms of b and x. So we can use this relationship and plug it into this formula over here, and we'll get a 2x is equal to x minus b, which gives us that 2x is equal to x minus 2b. So subtracting by our x and then dividing by negative 2, we'll get b is equal to a negative 1/2 x here. Now, since we have what our b is, we can go ahead and plug this into this relationship here. And this tells us that our a is going to be equal to a 3 divided by 2x. So we have our a, we have our b. We'll just plug it into this formula over here. And the solution we're looking for is going to be equal to a 2 cosine of 3 divided by 2x times the sine of negative 1/2 x. And we have our solution.